Welcome to EDU World Space.
So we have a surface sphere of radius r. So we draw the sphere in the x y plane.
Here's a clean and
It's gonna be
professionally
something
formatted
like
presentation of the
this,
calculation shown in the image.
more round, like
Application of the work energy
that.
theorem, wet. From the work energy theorem, the force F is given by
Yeah,
F
this
equals
is
with
the
frac text
x-axis, the
KE, where
y-axis.
KE equals
This
kinetic
distance
energy,
here is r,
S
and
equals
then
stopping
the
distance.
equation
If I'm
for
given
that
for object
sphere
A,
is
FA equals
x
frac
squared plus y squared is equal to
100,000,
r.
For object B, FB equals frac
So we have to
225,
consider
1500 equals
well, this is
0.15 text makes n. And force
the
ratio
sphere.
frac FA,
Ready?
FB equal
What
frac
is the area
0.10, equal
obtained by
fractional
cutting
result. A box frac FA, FB.
through two
Would you like a
parallel
PDF
planes
version of this
that
explanation?
intersect the sphere and are a distance h? So what is the area of this underlying region between the two planes? So the region is going to look something like this, and well, since we can rotate those two planes so that so the region would be something like that. So we can align those two planes, rotate them, so that it's gonna be like considering like the region between these two planes that are parallel to the y-axis. So the distance here is h. So well, we would have two numbers. So this distance here is a, the distance there is b. So that a plus b is equal to h. And well, this point here is gonna be, since it is centered at 0, this point here will be b, and this point over here is minus a. So a way to obtain the area of this would be to rotate this piece of the curve about the x-axis. So we would rotate this piece of the curve between minus a and b. We would rotate that around the x-axis so that we will have our area. So well, so that this area is that. So the area is gonna be the area of this region. This is the same area as that. So the area of this, since this is the the y-axis, the area of this area is gonna be the integral from minus a up to b, and then well, this function over here is the positive solution for y over this. So we have that y is equal to moving this over that side and taking the square root, because we only care about this positive part, will be square root of r squared minus x squared. So this is our function. This will be f of y. F of y is equal to f of x. This is our f of x. So that the integral would be the integral from minus a up to b of 2 pi times f of x square root of 1 plus f prime squared dx. So for this function, f prime is equal to, well, we have the square root, so we would have 1/2 of 1 over that square root like this, and then times the inner derivative of that, that is 2x. Well, minus 2x, so that minus 2x, so the 2 cancel, and then the 2's cancel, so f prime squared would be x squared minus x squared is x squared over that, over this without the square root, so r squared minus x squared. So that this would be square root of 1 plus f prime squared would be the square root of 1 plus that x squared over r squared minus x squared, and then adding these two, this would be the square root of 1 times that, so making a common denominator r squared minus x squared over r squared minus x squared. This is our 1, and then that plus x squared over r squared minus x squared, and then this simplifies to all these x squared cancel, and then we will have that on the top we would have the square root of r squared over the square root of r squared minus x squared. So this will be that, and then our function is this. So this integral is going to be this area. It's going to be equal to 2 pi times the integral from minus a up to b of square root of r squared minus x squared times this. Well, square root of r squared is just r for r positive, r over the square root of r squared minus x squared, and that dx. Something very convenient happens, these two cancel, so that this integral, this area will be 2 pi times the integral from minus a up to b of r times dx. So since those are constant, it will be 2 pi r, the integral of dx, but the integral of dx is just x evaluated at two endpoints, so 2 pi times well, x at b, so b minus that at a, at minus a would be minus minus a, and then we have the r there, so 2 pi times this times r, so that we obtain 2 pi r times a plus b, and well, this a plus b is h, the distance, h is the distance between the two planes, so that the area is going to be that pi times r times h. And well, something that does look a little bit strange is that, well, if we have a cylinder of radius r, so separately we have a cylinder of radius r, so this is a cylinder of this radius here is r. Now we consider the distance, the surface area of the resulting piece of cutting again by two planes, two parallel planes that are, so these two parallel planes, and then the distance between these two, this distance is h. So well, since this is a rectangular region, we can unfold this piece of the cylinder, and the wall is gonna be this. So we have something like this, and then that on the top, on the bottom, so that if we unfold it, is that region, and then this region here, that is the perimeter, that is equal to 2 pi times the radius, and then this distance here is h, so that this area here, um, it is also this number because the area is that distance times that distance. Since it is a rectangle, so it's going to be h times 2 pi times r, which is the same area as if we cut a sphere um, with, by two parallel planes that are separated at a distance h. So both areas are equal. Well, this is the same up to just reorder the, the numbers. It is the same.